Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to find the mole fraction of the substance of a particular substance in the vapor phase. So let's get into this. So let's read the question. We have a solution is prepared by mixing equal masses of CCl4, carbon tetrachloride, and CHCl3 trichlorine methyl trichlorine, or whatever the name is. So calculate the mole fraction of CHCl3 in the vapor phase at 43 degrees Celsius. Okay, so let's take a look at this. So they're giving us here the pressure of or the partial pressure of each of the substances at 43 degrees Celsius. So these are what the vapor pressures would be if we had the pure substance. So again, what we're going to be doing is we're going to be using Raoult's law to help us figure this problem out. So remember, Raoult's law is that you have the pressure, the partial pressure of some substance A, like some solvent, is equal to the mole fraction of that solvent multiplied by the partial pressure of that solvent for the pure solvent. So that's what it would be for the pure solvent. So we're going to use that to help us out. Now, one of the things you're noticing is that, well, how do we find the mole ratio? They told us, they didn't give any moles, they didn't give any grams, they just gave us these two substances and said that equal amounts of both of these substances, equal masses of these substances were used. That's going to be key to help us figure out this problem. So the first thing you want to do in working out this problem is to start by figuring out what the mole ratios are going to be, or the mole fractions. So how do you do that when you're not given any masses and you're not given any moles? Well, let's remember that the number of moles, right, is equal to the mass in grams divided by the molar mass in grams per mole. So when you divide these, grams will cancel out and you end up with moles, right? So we can use this to help us set up our equation. So we know the molar masses of the substances because we know the formulas. We can get the molar masses by calculating up the atomic masses of all the atoms in the formula. And so we can figure out the molar mass. But we don't have any masses. But we do know that these are going to be equal in mass. So we'll use that later, but we can at least set up the equation. So the moles of, if I write this out, the moles of CCl4 is going to be equal to the mass of carbon tetrachloride, CCl4. So we'll write that as MCCl4. And that's going to be divided by the molar mass of CCl4, or carbon tetrachloride, and that's going to be 153.811. So that's 153.811, and this is grams per mole. So that's going to cancel out, and we'll end up with moles on top. Now, if we do the same thing with the other one, the moles of CHCl3, and that's going to be, the name of that, if I remember correctly, is trichloromethane. So trichloromethane. And so that's going to be equal to the mass of the trichloromethane, CHCl3, over the molar mass of CHCl3, and that's going to be 119,369. So 119,369. Again, this is grams per mole. And so now we have these two equations. So the moles of CCl4 is equal to this. The moles of CHCl3 is equal to this. Okay, so now that we have the moles, we can set it up such that the total moles is going to be equal to these two. So let's go ahead and set that up. So we have moles total is equal to these two added together. So the mass of CCl4 over the molar mass, 153.811. And this is going to be moles. We're going to put moles on top since that canceled out. Plus this part here. So that's going to be the mass of CHCl3, right? And then the units are moles, divided by 153.811. Oops, my bad. Wrong molar mass. That's going to be 119.369. Okay, so the total moles, of course, is going to be equal to the moles of CCl4 plus the moles of CHCl3. So we have that written here. Now, we can simplify this. And this is where the fact that the masses of CCl4 and CHCl3 are equal. So let's write that out. So mass of CCl4 is equal to the mass of CHCl3. Well, if that's the case, then we can substitute. So since the question is asking us for the mole fraction of CHCl3, we can focus on that one, right, to calculate the total. So we can just replace one of these. We'll replace this with the mass of CHCl3. So now that we have these are equal, now we can add these together and simplify. So notice that the denominators are not the same. You can't add fractions that have different denominators. So you need to get the denominators to be the same. So if you remember way back when, the way to do that is you multiply, you take the denominator here, you multiply that top and bottom here, and then you take the denominator here, multiply this top and bottom. That way you'll end up with the same denominator. So let's go ahead and do that. So I'm going to take this and I'm going to multiply top and bottom. So 119.369 times MCHCl3, and that's going to be moles, divided by 119.369 times, and then that's going to be multiplied by 153.811. And then we're going to add to that, and we're going to do the same thing. We're going to take 153.811 and multiply top and bottom for this one. So that's going to be 153.811 times, again, the mass of CHCl3, moles, divided by, and then we're going to have this times this. So we're going to have 153.811 times 119.369. Okay? So now all we need to do is multiply these together. We can add these together since we have the same numerator or same denominator. We can go ahead and add these together, right? So then that's going to be equal to, if I add these together, what do I get? I get 273.249. So I get 273 point, what did I say? 273.249 times the mass of CHCl3 divided by, and again, since these are in the same denominator, when I add these together, I get the same denominator, so that's going to be 119.369 times 153.811. Okay, so now that I have this, now I can multiply these together and then divide whatever my answer by this. So this divided by both of those, and then I get, for my final answer, 0.014875, 0.014875 times the mass of CHCl3, and that's going to be moles. Let me double check. So 0.014875, that's correct. Okay. So now this is the total number of moles in terms of mass of CHCl3. So whatever this factor multiplied by whatever this mass is gives me the total moles. So I have the total moles here, and I have each of the moles of the substance here. So now I can calculate the mole fraction for both of these. So as I know, the mole fraction is going to be equal to the moles of A over the total moles, right? So all I need to do is take the moles of CCl4 and divide that by the total moles that I got here, and then take this moles of CHCl3 divided by the total moles there, and I'll get my mole fractions for both of them. So let's see what happens when we do that. So the mole fraction here of CCl4 is going to be equal to the mass of CCl4 divided by 153.811, and again, this is moles. And then we're going to divide this, oops, let me get this down here. Let me redo this, let me raise it up so it's better. So I have the moles of CCl4 over 153.811, and this is moles. And that's going to be divided by the total moles. So I'm going to take this and divide by that. So now I got this divided by 0.014875, and this is going to be multiplied by the mass of CHCl3 and this is moles. Now notice here that I have moles of CHCl3 on the bottom. I'm sorry, I have massive CHCl3 on the bottom. I have massive CCl4 on top. But remember, the mass of CCl4 and CHCl3 are equal, so they will cancel out. So these two will cancel out. Moles will also cancel out. So mass and the unit moles. And so we get this unitless fraction, which is what we want. So then we get, and then this is going to be 1. So don't forget that. So this cancels out with this, leaves me 1. So I'm going to take 1 divided by this, and I'll get my mole fraction. So that's going to be equal to, if we calculate this out, we get 0.4370. 0.4370. So 0.437. So now I got the mole fraction for CCl4. Now to get the other mole fraction, since we only got these two substances, I subtract that from 1. So the mole fraction of my CHCl3 is going to be equal to 1 minus 4, oops, I forgot the 0, 0.4370, and that's going to be equal to 0.563. 0.563. So now I have the mole fractions of both of my substances. Now I can use that to find the vapor pressure at 43 degrees for each of the substances in the mixture. So why do I need that? Because the other thing you want to remember is that the mole fraction is related to the fraction of partial pressures. So let me erase this and stay tuned. Okay, so how are those equal together? So let me show you. So we're going to go back to the ideal gas law. So we know from the ideal gas law that PV equals nRT. And if we can use this to solve for pressure. So pressure is equal to nRT over V. And so we could use this to find the partial pressure of some gas if we know these, right? So we could find the pressure of, for example, pressure of some substance A. And that's going to be equal to the moles of A multiplied by RT and divided by V. V for volume, T for temperature, R is your ideal gas law constant. And we could do the same thing for the total pressure. So if we have the total number of moles, we could add those together because of Dalton's law. Remember Dalton's law, the partial pressures don't affect each other, so you could add them together. Same thing with the moles. So I can get the total moles of our mixture of gases. And so I could find the total pressure by using the total moles in my mixture of gases. Multiply that by R and T and divide it by V, like so. And so now what I could do is I could find a ratio of the partial pressure of A to the partial pressure or the total pressure by dividing these two, right? So if I divide these two like so, notice what happens. So R is the same, so that cancels out. Temperature is the same because it's a mixture of gases. They have the same temperature, so that's going to be the same. We can eliminate that. And if they're in the same container, because they're a mixture of gases in the same container, the volume is going to be the same. So the volume cancels out, and guess what's left over? Look at what's left over. We have P, partial pressure of gas A, over the total pressure is equal to the moles of A over, the total moles. Well, what is the number of moles of A, the moles of A over the total moles? Well, that's the mole fraction of A. So that's going to be chi of A. So then this mole fraction is equal to the ratio of the partial pressure of our substance over the total pressure. So in order for us to find the mole fraction of CHCl3, all we need to do is find the total pressure and the partial pressure with regard to CHCl3. So let's go ahead and do that. So I'm going to write that over here. So pressure of CHCl3 over the total pressure gives us the mole fraction of CHCl3. So all we need to do is find the partial pressure and the total pressure. Okay, so let's go ahead and do that. So we're going to use Raoult's law to get the partial pressure of each substance. So we have our chi value. These chi values are not the chi values or the mole ratios of the substances in the gas phase. These are the mole ratios in the solution. So that is important to clarify. So the ones that we calculated here are the mole fractions of the substances in solution. We need to find the mole fraction of the substances in the gas phase, right? So that's why this is what we need to use. We're not solving, this is not the same as this. This is the mole ratio of the substance in solution. This is the mole ratio of the substance in the gas phase. Okay, so I want to make that clear. That's why these are different. Okay, so we're going to use Raoult's law. So the pressure or the partial pressure of CCl4 is equal to the mole ratio or mole fraction of CCl4 times the pressure of the pure substance CCl4. So they gave us up here that the partial pressure of pure carbon tetrachloride is 269 torr at 43 degrees Celsius. So we're going to use that. So this is going to be equal to 0.4370 times the partial pressure, which is 269. So 269 torr. And then we multiply those together, we get 117.553. So we get 117.553 torr. And then if we do the same thing for the partial pressure of trichloromethane, we're going to multiply its mole fraction, 0.5630, times the pressure, that should be pure. That's going to be the pressure of pure trichloromethane at 43 degrees Celsius. That's 400 torr. So we're going to multiply that by 400 torr. And then when we multiply those together, we get 225.24. 225.24 torr. And to get the total pressure, we're going to add those together. So we have 117.553 plus 225.24. And that's going to be equal to 342.793 torr. Okay, so now we have the partial pressure of both of the gases. We have the total pressure. So now to get the mole fraction of CHCl3 in the gas phase, we just take the partial pressure of CHCl3 divided by the total pressure. So let's go ahead and do that. So here we have the partial pressure. So the mole fraction of CHCl3 is going to be equal to the partial pressure, right? Partial pressure of CHCl3, which is 225. So 225.24 torr divided by the total pressure, which is 342.793 torr. Torr cancels out, and then when we calculate this, we get 0.657. And that is our answer, but let's pay attention to our significant figures. So here, when we multiplied and divided and all that stuff, we started with, well, where is it? We had our molar masses. So then here, what you'll notice is we have probably 3 sig figs. Where is it? So 3 sig figs are actually, we have 1. Here we have 3. So here, it would be hard to figure out what the sig figs are. Hold on 1 second. We won't worry about sig figs for this one, since we start with the molar masses. That's the only one that we use, and that was like 4 or 5 sig figs. So this would be the final answer, or if you wanted to round it to 2 sig figs, you could round it to 2, so 0.66. And that is it for this video. I hope you enjoyed the video. I hope you learned from this video. If you did, if you enjoyed this video, then please like the video, share the video, hit that like button somewhere over there. Make sure that you subscribe to my channel. Help me out, man. I need it. Make sure that when you subscribe to the channel, hit that notification bell and click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a problem or a question you need help with, or if you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me, and have a great day.